Hello everyone, you are watching Code with Shubhajit, and today we will be solving one of the medium level problems from lead code, which is spiral matrix. So let's go through the problem statement and let's understand what they're trying to say. So we have an m cross n matrix, okay, and we have to return all the elements of the matrix in spiral order. If we see the visuals, you can see that, okay, we will start from the 0 0 element, that is the index 0 0, and we will go towards the clockwise direction and we will traverse it like this, okay. If we take one more example where the size of the rows, like there are 3 rows and there are 4 columns, if they are different, how it will look the same only, but here they will not be that symmetrical as we have here, okay. But the spiral order, you should be able to understand how the flow or how the ordering will be there, the clockwise ordering, okay. So we have to print this as an output. So the output is list of integer, okay. So basically we will be having a list of integers. In that we will be having, for in this case, 1 2 3 4 8 12 11 10 9 5 6 7. That should be the output, if you can see here as well, okay. So let's go to the OneNote and understand how to solve this problem. So here I have taken a 5 cross 5 matrix, okay. So 5 rows and 5 columns, indexed 0 to 4 and 0 to 4 both sides, okay. One thing to note here is that I have not taken the elements because I just want to have the spaces empty. To explain you better, here we have to move in this direction, print the elements there. Then we have to move in this direction, print all the elements. Then this direction, print all the elements. This direction, print all the elements. And now this is the one cycle. And now this cycle will repeat. Can you see this, this, this? Here there is only, there is no element for printing. So it will again continue the cycle from here. Okay. So it's the third cycle of the row. So can you see a pattern here that if our array is bigger, then we have more number of these 4 cycles, okay. So these 4 cycles we have to repeat and we have to change some variables so that, okay, for the first time it was this, now for the second time it will be this. So we have restricted, you can see the row, the first row is now changed to this. You can also see the first column is also now changed to this, the last column is also coming back, okay. These all changes you are able to see, okay. So it means that we need some variable which will actually store these values, okay. We need some variable which will store, okay. Now we need to traverse the first row, now we traverse the second row. Also it will store the columns which needs to be traversed or how much we need to traverse. For that, what we need to do is we will take some extra variables, okay. So it's clean again. Now what I'm saying is we need 4 variables, okay. What are these 4 variables? These 4 variables are this one, which is top row. As the name suggests, this is the top row, right? Initially. Then we have as bottom row, BR. Then we have as left column, LC, left column. And this one we have as right column, RC. I hope the naming for 4 of them is pretty much clear. And these 4 will actually restrict us for taking the path of the spiral matrix. I will explain you how it happens now. Okay. So let's say initially, so it at each cycle we have 4 things going on. That is from left to right, from top to bottom, from right to left, and from bottom to top. Okay, you have to understand this. So the first step is left to right. So left to right, this is the first step. Okay. Now for this left to right, what we have to see that, okay, let me take this as x-axis and this as y-axis for just understanding, because these variables might confuse you. I will take x-axis and y-axis, okay, for now. So in the x-axis, you can see we have this tr. If we want to print all, if we want to store all these elements, that is 0 0 0 1 0 2 0 3 and 0 4, these indexed elements, then this tr is constant. So on the x side, tr will be constant, and on the y side, if we see that we can move from 0 till 4, which is actually from lc to rc. So here in the first loop, what we will be having, we will be having a for loop which will move from LC and which will go till RC, okay, and I plus plus. And at the answer list or whatever we have to return, we will actually add what? We will add the, let's take this array as ARR, the whole array as ARR. Let's take it, name it as that way for now. So ARR of TR, because TR is constant, the x-axis is constant, the y-axis is moving here. What is the y-axis? Y-axis is I, which will move from LC to RC. I hope this is clear for the first, that is the first left to right section. Now we will do what? The first row is encountered. Now we will move the TR to tr plus 1. That is, now the tr is pointing here. Okay, now the tr is pointing at index is equals to 1. Okay, that's good. So now our second section will start. What is the second section? The second section is this one. What we want here, if you can see, we want the elements at the RC column. Now the column is constant and the row is moving. Okay, so we want the elements at RC column, and what they will be doing, they will be moving from TR to BR. Can you see? Now this is the TR, index is equals to 1 for the row, and we have to move it till the BR, that is index is equals to 4. So what it will look like? It will look like something this. For I is equals to TR, I is less than equals to BR, I plus plus. Okay, and there what we will be doing, we will just add the, so here the x-axis part or the row part is I, so that is moving, and the column part is constant, so it is RC, so that's why it came as second. Okay, I hope you are able to understand this. So these all elements we are adding to the final array list or the final list which we want to send as answer. Okay, this is done. Okay, good. Now let's take the other ones here. Okay, here. Okay, so after we have traversed the second section, now we need to move to the third section. But before that, we actually have to decrement the RC. Now RC will be moving to RC minus 1. That is from index 4 to index 3. So now RC will be pointing to this. So this is RC now. Okay. Now the third section is going from here till here, which is along the BR, we have to move from RC to LC. Can you see that keeping the same row BR, we are moving from RC to LC. So we are moving from right to left, keeping the bottom row same. So how will the logic go there? And yeah, after this, I just forgot that after this for loop, we will have to increment TR. After this for loop, we actually have to increment, not increment, decrement RC. I also want you to understand a pattern. Okay, so for the first section, TR was constant. So that's why TR was moved to the next. For the second section, RC was constant. So that's why RC was decremented now. In the third section, if you see, BR remains constant. So after this step, we will be decrementing BR. I hope you're able to see a pattern here, right? So for I is equals to RC, I is greater than equals to LC, and I minus minus. So I'm doing minus minus because we are moving from right to left. We have to decrement the index. Okay, and what I will be pushing to the final array, that will be ARR of the row. What is the row? The row here is the constant BR, so which is BR, and the column here is I. Okay, I hope you are able to understand this. And after this, what we'll be doing, we will be decrementing BR. So now BR will be pointing to index is equals to 3. So this is the third section. Now what will be the fourth section? The fourth section will be going from BR till TR. Can you see? Going from BR till TR, keeping the same LC as the column. Okay. So we will move from I is equals to BR, I is greater than equals to TR, and I minus minus. Here also minus minus because we are moving in the upward direction. That is, we are decrementing the actual indexes. We are going from 3 till 1. Okay. Now what will be pushed to the final array? Every time it will be, what is the row? The row is I here because the row is moving here, right? Up. And what is the column? Column is constant, which is LC. And now you have seen that LC is constant. That's why LC will be plus plus. Why LC is plus plus? Because the direction of LC is towards this side, the direction of RC is towards this side, the direction of TR is towards this side, the direction of BR is towards up. Because we have traversed the outer row now, like outer section now, and this one cycle is completed. Now we will be going into one layer below. So for that, all of the elements should be shrinked so that we have specific area to traverse now. Okay. So now we have TR as this. So again the loop starts. For I is equals to LC, I is less than equals to RC, I plus plus. Okay, I forgot to do this. I forgot to move LC here. Okay, in the last step. So now from LC to RC, can you see from LC to RC, that is index 1 to 3, we will be moving with the same TR. So this will be the case. Now TR will move by 1 here. TR is here now. Good. Now in the second step, we will be moving the TR till BR. So we are moving from TR till BR keeping the same RC. So TR till BR keeping the same RC. TR till BR keeping the same RC. Now RC will move to RC minus minus. So RC is here now. Okay. Now the third loop, that is RC till LC. because we are going from right to left. So RC till LC, that is 2 till 1, keeping the same BR. Okay, so this is the path, keeping the same BR, and that's why what will happen is, now we have to decrement the BR, and BR will become this only. So now TR and BR are at the same index 2. Okay, now we are at the fourth level or fourth section, which says I is equals to BR, I is greater than equals to TR. That is this index 2 only. Okay, I minus minus ARR of I LC. It means that keeping the same LC, we want to move from BR till TR, but BR and TR are pointing at the same element. That's why it will be just a dot. That is, it will just be adding 2 comma 1. That is the element 2 comma 1, whatever it will be here. Okay, and after doing that, we will be moving the LC to LC plus plus. Now you have to understand that both LC and RC are now pointing to the same index 2. Both BR and TR are pointing in the same index 2. Okay, good. But now one more loop starts, or one more like third cycle starts. So I is equals to LC, I is less than equals to RC, I plus plus, which is this point only. What we'll be doing? We will be pushing the ARR TR of I, which is only this element. Okay, which is only this element. Now you are able to understand, after doing this, what will happen? We will be moving the TR to TR plus plus. So this will move the TR here. Now TR becomes 3. So TR becomes 3. Okay, now you also have to understand that we have to break this loop at any point, right? These 4 sections which are running inside a loop, that should break, right? Otherwise it will be just like infinitely moving. So what is the breaking point? The breaking point is whenever TR goes beyond BR, or whenever LC goes beyond RC. These are the breaking points. Okay, so as we are moving TR to TR plus plus, we will be having a check. Is TR greater than BR? If that's the case, we will break. Here we are moving RC minus minus. So here we will be having a check. Is RC, is it lesser than LC? Because RC is going left, LC is going right. So if RC is now lesser than LC, it means we have to break. Same way here, as we are moving BR minus minus. So we'll check, has the BR decreased from TR? In that case, we have to come out of the loop. So here is LC plus plus, which means that we have to see that, okay, is LC greater than RC? In that case, we have to come out of the loop. So these are the 4 breaking conditions from this loop, okay, which we have to understand. Okay, so this actually I have written the code as well, but I will code it out separately so that you can understand how things are going on. But this is the whole logic which is working. Now let's go to the code part and see actually how it will be coded out. Initially I want to have variables for storing the size of the arrays. Okay, so matrix dot length in 10 is equals to matrix 0 dot length, because this is the row and the column, right? Matrix 0 dot length because the 0th index is now this whole, so this one, right? So matrix dot length, it means that the array part, that is for, let's say in this case the matrix dot length will be 3. The matrix 0 dot length, that matrix 0 is this part, this one, 1 2 3 4, so that's length is 4. So the row part, the number of rows and the number of columns, we got it right. Now I will be having a answer array list which I will be returning. So it is something like this. Okay, and I explicitly keep this as an integer just for safety, type safety. Okay, so after it is done, what we will be doing, we will be having 4 variables. So these 4 variables are, as I have mentioned, that it will be top row, which is 0, it will be bottom row, which will be m minus 1. So if you see here in this case, right, so the top row is 0. What is the bottom row? M is actually the matrix length, that is 3. So 0 1 2, by index wise it is index 2, right? So that's why br m minus 1. Now same way, left column will be 0 and the right column will be n minus 1. These 4 variables are done. Now you have to understand one thing, that we have to have a loop running every time, because that is something which we don't know, that how many times the spiral section will be moving till it reaches the middle point. Okay, so we will be having these 4 for loops. Okay, these 4 for loops will be running, but they will be running inside a while loop, and that while loop, how many times it should run, okay, that we don't know, because we don't know how many times the spiral matrix will like go inside. So for that case, what we will be doing, we will be having a while prove, which will be running infinitely. But we will be having break conditions inside based on these four conditions I have told, right, which are written in blue: TR greater than BR, RC is less than LC, and so on. So in these conditions, the loop will break and we will come out of this while loop. So that's the scenario. I'm putting the while loop just to make it an infinite loop, and we will break out whenever we need. Okay, good. So the first part is for I is equals to LC, I is less than equals to RC, I is less than equals to RC, and I plus plus. It's the same thing. So I will be actually just coding the things out at like at once, and then I will come back. Okay. Okay, guys. So I have actually written the whole code. So just to explain you the things in brief, it's the same code which we have used while explanation here. Some of the parts I want to explain you. So can you see this follow? This is the same as it is left to right, for top to bottom, for right to left, and then from bottom to top. Okay. Here we have the increments based on whatever line is constant. So what I'm saying is, for the first part TR was constant, so TR incremented. For the second part RC was constant, so RC decremented. These things. So this is done. Now the breaking condition, there are four breaking conditions, as I have mentioned these here in blue, right? So those were also added. So if those conditions are true, then I will break from the loop and I will come out of this while loop. Okay. Okay, so let's talk about the space and the time complexity now. So if you see, for the time complexity part, we are actually traversing. So here we are actually traversing each element of the array once for populating the final answer list. Okay, that's why the time complexity will be big O of the size of this array. That will be m cross n. So this array, the number of rows is m, the number of columns is n. So big O of m cross n is the time complexity. Okay, and what is the space complexity here? The space complexity would be counted as, apart from the answer or apart from what you are returning, how much space you are taking. Okay, so if you see in this case, we have to return a list of integer. So we have taken this answer. Okay, list of integer answer. So I will not take this inside the space complexity. Okay, because that has to be returned. What comes inside the space complexity is these four variables, and these four variables will be declared, and it doesn't depend on the size of the 2D matrix which we have. Okay, that's why, and we are not actually taking any extra space. We are just traversing this already given 2D matrix. So that's why the space complexity here is big O of 1. That is a constant space. Again, I am saying that this answer will not contribute to any space complexity because that has to be returned, and that is mandatory to be initialized. Okay, I hope you are able to understand this, and I will also run it in front of you just to see if things are working fine or not. They are working fine. By the way, I have checked that before as well, so no worries. But you can actually submit it and see if things are going well with all the test cases or not. I will highly encourage you to uh, have some dry run over some bigger examples or some different type of examples where m and n are not same, the sizes of the rows and columns are not same. So there you can actually check that how the clockwise line goes in the spiral matrix and how it prints the elements. Okay, so that will be a homework to you, but that's all from my side, and thanks a lot for watching this. If you have any doubts, put them in the comment section. I will be really happy to help. Goodbye.